This is Code.org, and it is Store Management Project Day! Boo, 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 boo. Congratulations, you're a store manager, and I'm a store manager. Now, what type of store? So, you should have your project planning guide. If you don't, guys, remember, if you navigate to the lesson and click on Lesson Resources, it will be there as a link. Regardless, here's mine. I've started upon it, right? So, the name of my business, because I am very inventive and exciting, or my business type is a furniture company. The superclass is furniture. My subclasses are going to be a couch and dresser. UML, this is used throughout computer science and by software engineers. It's a real thing. They're useful for planning things out, so I'm glad we're doing one here. My superclass, is going to be furniture. My subclass is couch and dresser. These two classes extend from furniture. So dresser, that means since furniture is going to have the attributes name and weight, and keep in mind these will be instance variables, and we'll get there, but it's going to have a name and a weight. The methods that we'll have for furniture, you'll be able to get the name, get the weight, set the name, so change it up, set the weight, and then also the Tostring method, which we've seen recently. This will just declare to be able to get all the information at once to put it out to whoever's using the program. Now for couch and dresser, set up very similar. The dressers will be an int, it's just going to be a number, and that's an attribute. Couch will have a string, and that's going to be its fabric. So, and these are suggestions. I could have done outdoor for furniture as Boolean, yes or true or false, and other items here. Now, the method's very similar for both of these. They're going to be getters and setters, right? Get or access the number of drawers, set or mutators that will allow us to change the number of drawers, and then tostrings that will output the information. Now, this is just kind of me mapping out what's already up here, how we're going to be able to get and access the information, and what the customer can expect. Right? So I kind of just ran through this. I didn't really complete it fully, but to give you an idea of the direction you want to take this in. That being said, I want to start with my favorite part, or get going on my favorite part, the code. So here we are. I'm actually not going to mess with my console.java right now, right? Especially since it says write your superclass and subclass. All right, well, my superclass is furniture, so I'll do what the instruction says. You know, teacher instructions, like them. Furniture.java. Create. Now, what goes at the top of the class? Pop quiz. I'm just kidding, guys. Use your resources. So I'm going to click right here. Oh, look. Public class council. Okay. So I can even copy this over if I'm not sure I'm going to get it. Right. Public class council. I'm going to actually write it to be fancy. Public class furniture. And it has to match exactly what I have up here, but no dot. And then a curly brace. Let me hit enter. Cool. Now, what does every class need? Classes are going to need, these classes are going to need a constructor. Now, not any type of constructor. First, we're going to do a no argument constructor. And that means, there's not going to be any parameters, the default. So let me hit enter, and we know all about constructors at this point. So let me just go ahead. We're going to do public furniture, because a constructor must match exactly the name of the class. Now, there's no arguments, which means it's not going to accept any arguments, so there's going to be no option for parameters. So, kapow, right? And bam, I'm done with my constructor. It's a naked, empty, sad constructor. However, this isn't how it's going to stay. So we got a few things. First, we need our attributes in here, right? I said I'm going to have a name and a weight. Those attributes are instance variables. That's a fancy way to say they're variables at the top of my class outside of any other methods, and that they're variables that can change. Other things can use them. So I'm going to do string name, if I can spell it, and I'm going to do double, right, because I'm allowing the weight to be a decimal, double weight. Double weight, that's kind of, anyways. Okay, and although variables in Java, instant variables in Java like this would be private by default, I can go ahead and put private just for clarity, that anything outside of the class isn't going to be able to access this, but the methods within will. All right. Now with that done, you'll notice, wait a minute, this no argument constructor, that's fine, we still don't have an argument. you will want to set some form of a default value. So if they attempt to instantiate a furniture object, right, if we went over here and said, you know, my fancy new chair, Mr. Chair, is, if I went over here and did this, furniture, Mr. Chair is going to equal new furniture, it needs to have some data in it. Otherwise, it's just all undefined information. So when it runs this furniture constructor, I'm going to say, okay, name. This is kind of up to us. We could leave it as empty. I could leave it as unknown, right? I could do, well, pretty much anything with it. In my program, I'll just go ahead and leave it as blank. What that will allow us to do, because this is a string, it's just an empty string, is it allows us to define the variable, but not necessarily have real data or a real or other characters in it. And then my weight, everything has a weight. So I'll just say my weight is 0.0. Fancy. And now it's a double. All right. So that's good for the default constructor. Now, a no argument constructor. Now it wants a parameterized constructor. All right, so I'm going to cheat a little bit, and I'm going to do copy. Why work harder than we have to? And then I'm going to do right click and paste. So public furniture, great. The only difference now is it has, well, parameters. So I can allow them to give us information that we can use. So I'm going to write string, and I'll call this one new name. And I'm going to do double and new weight. Yes. All right. Now, in this situation, what I'll want to do, and to clarify up here as well, I'll get back to that actually. What I'm going to do is say name is going to equal new name. And then weight is going to equal new weight. Now, students, I want you to realize something, that oftentimes in programming, you'll see this, string name. And people will say, all right, well, but I have name up here already. How can I do this? The way we make sure that a computer understands what is being referenced, right? Because if I have them pass a new a parameter called an argument with the parameter being a name, the computer's like, wait a minute, what do you want name to be equal to? You want it to be equal to name? Huh? And that's when we would have to use the term this. We should really use it anyways, and I like doing this new name. I think it makes it more clear. But what we want to have in front of all of these is this. Now, again, you'll see this a lot, name and weight, and it would completely not work unless you have the this in front of it, because we have to identify, we have to tell the computer that that's fine. Right now we mean name, right now we mean weight. However, when we are giving something a value, we're giving the value to this name. When we're giving a value to weight, it is this weight. Okay, so I guess I'll leave it like that. Either way is correct though. I'll go ahead and again, just for clarity, add the this keyword up here as well. All right, now we need accessor methods. So accessor is just the get ones. Let me punch in that code and then talk about it. All right, so here are my, shrink this down. These are my accessor methods. All it allows me to do is, or allows the user to do, is once an object is instantiated, they can use get name to get the name or get weight to get the weight. Now, I like to test stuff as I build, guys. It's just better practice to do that. So I'm going to head over here and furniture, I'm just going to call this test furniture, right? And I'll probably end up deleting this, but I want to have some test data types or some test instances. And now, since I have this, I'm going to go ahead and say my test furniture. Now, let's see here. My default weight, right, because this is a no argument constructor, my default weight is 0, 0. So I'm just going to do a system.out.println. I'm going to say default weight. And then all I'm going to do is a plus and say test furniture get weight. Let's see what it says. If it even works. Weight is 0, 0. Cool. And now name should just be an empty string. Yeah, see, nothing. That makes sense. Okay, So that one works. Our default works. So now let me try test furniture. I'm actually going to give it a name. My name is going to be computer chair. Yeah, yeah. Notice the pattern here? Computers. Yeah. And the weight, 21.5 pounds or whatever, because I know the exact weight of a computer chair. That's not true. All right, now it's not going to be default weight. This is going to be the actual weight. So I'm just going to call this weight. 21.5. Cool. And now if I do get name, yep. So that all works. All right, let me go back to weight. Cool. That's so far so good. It allows us to get access or to return the actual name and weight each way. Each way. Way. Anyways. All right. So now we need our mutator methods. Fancy way to say set. Don't let this terminology scare you. How do you mutate something? How do you change something? You set it. So let me hammer some of this up. All right, so I have two different ways of doing this here. I want to go over something first, though. Notice I said public void. Mr. Kaiser, why? That is because we're not returning anything. So when we set a name, I don't expect the computer to give me something back, right? As opposed to when I do get weight right here, I expect the computer to provide me a double, which is just the fancy way of saying decimal point, right? So when I do get weight, notice it says double here, because I'm asking the computer to provide them that information, the double. Now, when I say set weight, notice it's a void here, because the computer's not going to give me anything back. However, I have a parameter. I'm allowed to provide the computer the new weight right here. I wanted to point out one distinction that is super confusing, and I did it here, and it's confusing. So in this, I have the string new name. New name is my parameter. I then tell the computer, hey, I want to give name a new value. Well, what is name? Name in this situation right here is referencing the one at the top of the class, right? The instance variable way up here. I know it is because there's nothing else named name here, right? Nothing within this method. So I know that whatever's happening here, this method will set the name to whatever string I give it here. It will set the class's instant variable name to be whatever string is passed. Now down here I did it a bit differently because these are the two ways I often see students do this. Here I said double is weight. You will notice now that with this being weight, weight is identical to the word weight up here. However, these are different. This weight I am defining within the method signature. This weight is the parameter. This weight is not this. And that's super confusing. However, this is a very common practice in computer science. And the way we distinguish it is we say, computer, get this weight, which is the class's weight, which is the instance variable weight, which is the weight way up here. This weight has a new value. What is its new value? Well, it's going to be equal to weight. What do I mean here by weight? The weight that is within the method signature. That is that. This guy is way at the top. And this dot weight is what what we use to let the computer know it's the thing at the top. The reason I don't have this here, and I could put that here, is the computer will not be confused. This isn't necessary because the computer knows there's no other option, right? Not within this method. Yeah, there's name up here or whatever, but within this method, the only other option is new name. So it's not within this method, so it has to look outside of the method. It's not going to just jump and look in any of these random methods. It ends up back at the top. All right. So that all being said, I'll change it over, but I want to make that super clear because it's often a hang up for students. All right, that's dot name. Cool. Getters, setters. Let me double check these. Okay, so now after I printed the weight right there, I set the weight and I set the name. Then I'm going to print new weight. Let's go ahead and print the new name. I'll just copy and paste it to check these. All right, original, set, print again. And there we are. Computer chair, 21 pounds. Mr. Desk, 81 pounds. Cool. Now it wants us to do this again, except with our... Oh no, first I got to do toString. Okay. bam, bam. That's going to be one more method. And now this one's going to return a value. So public string to string. And now I like to do it like, I'll do string text is going to be equal to name plus, and now I'm going to do the weight. Now, if you're curious, you could use this here as well, right? All this is saying is, hey, make sure you're only checking the variables or using the variables within this class. The reason I'm not going to need to do that is there's no confusion. Within this method, I'm not using name up here in the parameter whatsoever. Or weight, for that matter. All right, so there's my text. I can return this directly, but I like doing it this way. It's easier for debugging return text. Cool. This is all looking good. Let me just make sure. Right there. Bam, bam, bam. Cool. Alright, so at this point we have our superclass furniture. Now I need my two subclasses. I was going to do couch and dresser. And honestly, they're going to be very similar. They're going to have a lot of similarities to our furniture class, except they're extended from it. So let me magic those up, and then I'm going to walk through some of the code and the similarities and their construction. And ta-da! Through the magic of the internet, here's couch, here's dresser, my two subclasses. Now, there are a few differences. It is very similar to furniture, both of them are, but there are a few differences. First off, it extends furniture, both of them do, and that's because these are built on top of the furniture class. These are subclasses. This is part of the requirements. It is in the rubric, right? So, where are we? Overload, nope. Subclasses that share attributes behavior with the superclass, and they use the superclass constructor. So you have to have extend to properly make a subclass. You need to use the superclass constructor. Kapow, that's this. What this does is when a new couch is created, a new instance of a couch is created, it tells the computer, hey, you also have to go run the super. The computer says, what the heck is super? It must be something above this. Oh, furniture is above it. Plop. That means that the couch will also have a name and a weight and access to this stuff. That's what super does. Now notice this super has no arguments. That's because it's going to run the default, the no argument constructor. Now, this super down here, I added arguments to. That is because when they create a couch, when they instantiate a new couch object, then they want to set the weight or they want to set the fabric of their couch. They're also allowed to set the name and the weight of the furniture item. Now I don't, since these are not variables within this class, they are going to be in the class furniture. But remember, when the class is instantiated, when an object is instantiated from this class, couch will still, just like normal, have a weight and a name and a fabric, right? But it's all layered. It's up here. So they're allowed to set the weight and the name for this couch object. All right. Get fabric, getters and setters, it says the data type that will be returned, it returns fabric, which is a string. Set fabric, this one I did a bit differently. I said fabric update. The reason I called this fabric update is because then I don't have to use this keyword here. Because my program already knows I must mean this fabric, because within this method, there's no local variable, there's no local argument parameter with the fabric key, with the fabric name. Now keep in mind, you do also have to use the this keyword within your superclass and subclasses to get full points. But I already did that up here. Okay, cool. Now, I went ahead and overrode the toString method. Now, why did I override it? And I'm saying override it. Remember, overloading is having two constructors like we do here and here. This constructor has no arguments. This one has, we put it in here for 3 parameters. So overloading it is when the computer will run by default. If I call couch with no arguments, it will run this one. If I call it with 3 arguments, it will automatically know to run this one. That is overloading a method. Overriding a method is forcing the computer to run a method with the same name. So when I create a couch object and I say do toString, and again, this is what they showed us in a previous lesson, and it's why I did it. Since we're required right here to make a toString method, I said, why not? You're not technically required. It doesn't say I need to override them in subclasses. You can even see, it's just overload, overload. But why not? We know how to do it. So I went ahead and created an overriding method within couch. And so now, instead of running furniture toString, actually, I think I do. Yeah, in this one, I say products couch. I do a new line character. I set this all equal to text. Then on the next line, I say text is going to be equal to what text used to be equal to. Plus, I could have just done this. It would be the same thing. Why not? Text is equal to whatever text used to be equal to, plus, hey, super. So what am I calling there? The class above it, run the toString method. It now has to go up to furniture and grab this information. It returns it. So now we have name and weight, and then I add fabric to it and spit it back out. Dresser, now almost everything here is very similar to the same. One distinction for set drawers, right? Keep in mind drawers is an integer. Drawers here, I named it just drawers. And that way I do need to use this to make sure the computer understands. As opposed to fabric, I named fabric update. So I didn't use this dot fabric. Over here though, I did drawers. So I've got to use this dot drawers so the computer knows I need to change the value of this. What am I going to set it to? Well, the drawers here is referencing the one that we are, the named parameter. All right. Now, the toString method here, again, I am overriding. I did this differently just to show you guys some stuff. So super get name. I could call toString directly. Instead, though, I'm going to call the get name method. Now, it will know to go one up to furniture and run get name. However, notice that I did this dot get weight. The reason I wanted to do this dot get weight is there's no weight method here. There's not a get weight here. So Mr. Kaiser, this is going to break. It's not, because that is how extending a class and a subclass will work. The code, when it is compiled, the computer will automatically look, when we run this, it's going to say, get weight, where? Oh, there's no get weight. Oh, wait a minute, furniture. And it's going to automatically bump up and run this get weight. Now, if you are worried that somehow we would also write a get weight here, and you really want to make sure you run the one above it, you run the one in the extended and the master class and the super class, then you use super. However, I know this is the case, and I think it's cool. All right, all that being said, let me throw in some test stuff, show you guys how this works, and then let's move on. All right, and once again, through the magic of the internet, I've written out some tests here, guys. Furniture, right, we already demonstrated that. I do a toString. I created a test couch. I named it Happy Couch, because our couch is happy. It's 152 pounds. It's not shy about that. It's a very plush couch. That's a word. And its fabric is wool. I then change its fabric to silk. They're the only two fabrics I could think of. Don't judge me. It's wool, it's silk. Wool would be a horrible fabric for a couch. Oh well, it's not mine. Well, maybe it is mine. Anyways. One, I change its weight. I'm going to print that. Same thing, cool dresser. Here's its weight, 5 drawers. I change its drawers. I change its weight apparently again. I could also change its name. Let's be fancy here. And this time I'll change the name. Set name, cool dresser. Friendly dresser? Sure. Let's see what we got. Bam. Here's my product, couch. It's a happy couch. Here's its weight. Here's its fabric. Now I updated the couch. Still happy couch. I changed the weight. And the fabric's now silk. Here's my dresser. Cool dresser. Its weight. Oh, do I not have a comma there? Interesting. Bloop. I got it. Bam. Okay. Anyways. Cool dresser. Its weight is 52.5. Drawer count's 5. After the update, name is friendly dresser. Weight is the same, but I have 12 drawers. Neat. All right, and in day 2, we'll add the interactivity to the class. But so far, so good.